Here's a video about the line. It is a city in Saudi Arabia that is very strange, and I was wondering about the mass transit, and so I did some very complicated mathematics surrounding the mass transit of the city, just trying to figure out how many buses you would need to move everyone around, because the personal automobile is not going to work. So here's the length of the line. This is taken from the video. The population, which is also taken from the video, I'm going to take their word for that. But I don't think they fully thought through the commuting. So let's do commutes right here. Percent of commutes that are 25% of this distance, 50% of this distance, 75% of the distance. Trips per day per person. So then you just do multiply by the percentage of 170 times the trips per day times the people. You get total millions of kilometers per day. These three numbers, add them up, 2 trips per day per person. That seems fair, right? This is 1.3 billion kilometers per day over one road that is 170 kilometers long. So just think of how busy this road is going to be. That's the problem. All of those trips stacked across that single road. So let's move on. Let's move further. If rush hour is X% of traffic, we have a range right here. Then X kilometers per hour during rush hour, you just take this number, multiply by these figures, you get this kilometers per hour during rush hour. I believe this includes the morning and evening rush hour. So we're assuming buses during our rush hour. We have our bus persons per bus of 20 or 40. Then you have your speed of the bus in kilometers per hour, 75, 100, 125. You get this range based on your speeds and how crowded the bus is. So at minimum, we need 87,000 buses during rush hour for the whole city. This sounds extremely crazy, but that's one bus per 100 people, which seems like it's within the range of what our mathematics should be, right? This is 290,000 buses. So moving further, we have this range. From this range, it's just transported, and we have our required number of lanes of road for this main stretch of transit. 8 lanes, 10 lanes, 12 lanes. You have to divide by 2 for each side. So this is a 4 and 4, 5 and 5, 6 and 6. So now this is our buses per kilometer of road. You just take the number of buses, take the number of lanes, multiply out. You divide by this number. So, I forget the exact formula, but anyway, I checked it. So at minimum, we have 43 buses per kilometer per lane, because this is dividing by lane. See this? Now we have our length of bus, the final area here. Our length of a bus is 12 meters. Just look this up. We can calculate our percent congestion. This is during rush hour. So if we have 4 lanes on each side and all of the buses are all filled up, our best case scenario is 77% congestion. So 3/4 of every single lane of road on 4 lanes on each side are all buses that are all full, because this is the best case scenario. If you go down to 20, if the buses are half full, you're looking at over 100% congestion. So the only logical thing to do is add more lanes. Let's go over to 6 lanes on each side. You're still at 50% congestion, best case scenario. Worst case scenario, with a 12-lane road, you're at 170% congestion. So then let's say we go to 12, 16, 20. 10 lanes on each side. Now we're finally clear in all scenarios with this. Let's say it's not as bad. We have 8 lanes on each side. This is looking pretty good. Our best case scenario is still 40% congestion. So in order to get a reasonable number, because I don't think 12 is going to cut it. Look at this. This is not going to cut it during rush hour. In order to get a reasonable result, you're probably going to need 8 lanes on each side for that main road. Which, I guess it's doable. The next video will be discussing a train system. I guess I'll just build their whole transit system. So they discussed a train system in their proposal, and they said, oh, well, the max speed of a train is, 400, 500 kilometers an hour. What they're clearly not considering, what they're clearly not taking into consideration, is the number of stops the train has to make, and then how close those stops are to your destination. So the more stops you have, the closer you are to your destination, but the more acceleration and deceleration the train is making, the more unloading and loading and unloading the train is making. So the average speed of that train goes down more and more and more the more stops you make. This is why I went with buses. I should have probably said that in the beginning of the video. But this is why I went with buses, because then you don't have to worry about the number of stops, and you don't have to worry about loading and unloading, because each bus is like its own unique vehicle. So the next video I'm going to do regarding demolishing the line is going to talk about the train system and the acceleration and deceleration of the train, the unloading and loading and unloading of the train, the length of the train, stuff like this, how far the train stops will be. I guess we'll do trains and buses. So that'll probably be the best way to do it. And yeah, we can try and combine the train math with the bus math, which will be very difficult. I'm not sure if I'm going to be able to do it. There's there's already a lot to the bus math, as you can tell. But look for part 2 of demolishing the line, probably in the next few days. And then maybe I will do a part 3. Since this is kind of an interesting topic, and so many people compare my arcology to the line, when really they are quite different. They're vastly different. I think if the line was wider, it actually would be a decent idea, and if I fixed their transit system. But right now it's just too narrow. It should be, it was like 500 or like 200 meters wide. Why are you making it so thin? If it was like 1 kilometer wide, it would be much better. Then it would be like, you're like, oh, okay, that makes more sense. But like, you're making it so thin and so tall, and the thinner and taller you make it, the longer it is. You don't want the line this long. I understand one line. That kind of makes sense in a really weird way, is to have one spine transit system. But it's almost like they're bragging about how long it is, which is a bug, not a feature. It's a con, not a pro. So if they could make the line fatter and then maybe like 30 or 40 kilometers, that would be a much better scenario for the congestion along that spine, along that main transit route. Anyway, I've probably went on long enough for part 1. Expect part 2, maybe part 3. And remember, a single dream is better than 1,000 lines. Or a single arcology is better than 1,000 lines.